Hey everyone, how are we doing? We are live on Stat 201. Who do we have in the office hours? We'll see here. Live chat, pop out chat. Oh, Aaron, good to see you there. What shall we do? Let me wake up Mewbot and throw out some points. Mewbot, why are you sleeping on the job here? Getting off to a start here this morning with Mewbot waking up. Aaron, good to see you. Whatever questions you have, drop them in the chat. We can get started on work. We can do data analytics. We can do chapter 3 homework. Good to see you too, Aaron. Thank you so much. We'll throw you the point. Well, Mewbot's waking up. Mewbot's waking up. Got to wake up Mewbot. He's a sleepy Mewbot, sleepy Mewbot, and he should give out those points now. What do you want to work on? What can we get done? I'm going to pull up to my Pearson. Mewbot is awake. So Mewbot is throwing out those points, his Mewbucks right there, as we call them. And we are getting started. Edit the video so we can add the timestamps. Pearson sign in. What shall we do? Chapter 3 homework. That is a good call right there. But a lot of people are like, you know, chapter 3 homework would be really nice to get done. And huge, this is a new mic this semester. We were using a lapel mic. Got it over here somewhere. I got the old lapel mic back here. So we used to use a lapel mic, the ones people like clip in. And that was nice, but the audio quality was like an 8 out of 10, but I'm really pleased with this mic. It uses a cloud lifter and Haslam College of Business. I just have to thank endlessly because it really is like, I'm like, hey, can I get a really good microphone? They're like, yes, you can. Your students are like, thank you so much. It's one of the ones like Joe Rogan uses. We're loading up the homework right here in the background. So this is, I think Lex uses it. Haslam is always the best. I'm a little partial. Brian's a little biased. I can't help that I'm a little biased towards Haslam. They treat me very well, and I'm very lucky. So gotta say, and I think it's mainly, and I gotta say this, it's also like we use it, and we get the ability to get stuff. So we try to help people. In one of my ways that I work with Haslam is we try to help instructors up their game and do better things. But the hardest thing about being an instructor is you wear a lot of different hats. You do a lot of different things. You sit on different committees. And so everyone wants to be a great teacher. But the problem is you might have people telling you 10 different ways to be the best teacher. So it's kind of tough at times, and we're almost got it all loaded up. So, and then sometimes you just don't want to switch, what you're doing because that's a lot of work. So it's like, oh, now I got to switch my whole thing. Got to switch our thing. Speaking about switching over, it is time to start the homework. Let's do it. Okay, we got the homework question 1. We can do some chapter 3 quiz. Put it in there. Thank you so much, Aaron. So far. You've been a great professor so far. I don't know, Brian. You might not be a great professor, but we'll hold judgment. So we're gonna do, and Nemo, feel free to put any questions in the chat. This one I think has people stuck sometimes, or it's the later one. So we are right here at the 4 to 3 mock. Stat 201, chapter 3 homework. And feel free to put any question you want in the chat. If we're doing one, we can just start doing it. So this is, well, I don't know why a college president would think that higher education has a poor value, but this is a conditional distribution. It says what % of college presidents. So what you have to do right here is you have to go in and you have to do of the college presidents. So you go here, and this is called a conditional because you're only looking at the distribution of one variable, whether someone is a status U.S. adult or college president, and if they think it's poor. So the really not so fun thing about this is we're gonna have to find the row totals. The row totals are the amounts of presidents there are, and we're gonna add these up. 33 plus 22, whatever that was, 630 plus 181, and we get 811. And we could do the other one real quick while we're here, just we might need it. 328. And drop any question, Neiman, you want in the chat, and we could get to that. We will do it. Just say, how about this question? The quizzes have a lot of different questions, so I can't always do the full quiz. I think people sometimes be like, where's the full quiz? I don't, excuse me as I hiccup. I don't always have the full quiz posted. No, but usually videos can be found. So we're gonna divide 33 by 811. Because that's how many are the presidents who think it's poor. So of the presidents, what % think it's poor? There we go. 4.07. We'll see how it wants it entered. 1 decimal, so 4.1. Research group. Yeah, we'll do one here soon. You got it. And so of the college presidents, which, what percent of college presidents think it's a poor value? So what did we do wrong? Times this by 100. We need to check our work. What percent of college presidents think that higher education provides a poor value? Well, it looks like we have a math error as far as I can tell. So let's go ahead and check our math again. And everyone in the chat's free to check the math with me. 33 plus 226 plus 630. This is adding up to more, I can already tell. So we do have a math error. That's the way we roll here. 1070. Math errors are what gets you every time. So 33 divided by 1070. We're going to do this one in our head. Beep, boop, beep. How you do math in your head. It's going to be 3% on the dot. There we go. And so the math on that was, just to show again, 33 divided by 1070. Who needs calculators? We don't need calculators. 3.1 to be more exact. S, good to see you there. Drop a question in the chat. We're already making mistakes. We went mistakeless for a few days, and then we made mistakes already starting here. Just a math error. What percent of U.S. adults think that college provides either a good or excellent value? And we need to now take U.S. and do the U.S. adults and good or excellent. Once again, your math is what's going to matter here. You're just going to take of the U.S. adults, what percent provide a good or excellent. So you move the conditional over to there, and you now have of the U.S. adults, what percent provide good or excellent. And so 741 plus 113, there it is right there, divided by 2135. And if you did the math right, you get the right number. If you do the math wrong, you get the wrong number. How did we do? Remember, we are timesing this by 100 because it is a percent. And we have mathed right now. We were doing the math right. Now we're going to do the same thing for college presidents. So if you look at what we do here visually, we're going to say of the college presidents, what percent think good or excellent. We now know that we have the right values over there. And we're just going to box this in right there. So there is the of the college presidents. And we're going to go right here. 630 plus 181 divided by 1070. And we get 75.8. You can times by 100, round to 1 decimal, and you can see it right there. Rounded is 75.8. And these are conditional distributions of the college presidents. What percent believe college provides a good or excellent value? And these are very different. You can see college presidents are more likely to say it's a great value. The mosaic plot would have a big gap in it. We could try to make it even. Could probably make it pretty quick. Here it is. You do not have to do this. This only takes me moments because I've done this a lot. Do not worry about doing these steps right here. I just want to show you the visualization. And you should know that when you visualize a contingency table, you can visualize it in a mosaic plot. And I do kind of like doing these things a little quickly sometimes because it kind of shows if you know how to work with data, in under a minute, you can get the visualization right here. So take a look where you have a lot more presidents think it's a good or excellent value. And this is a total of the 75.8% we got total. And then here's the good or excellent. There's the do not know for US adults, but the good or excellent down here. And you can see the big gaps. And that is a statistically significant difference. So anyways, you don't need to do that part. It's just you're saying there is a big difference. And the college presidents have a better opinion. And we saw that visually and we saw it mathematically. Is it reasonable to conclude that 5.29% of U.S. adults think that higher education provides an excellent value? Why are we not? And so one of my least favorite questions right here, because they're basically just wanting you to do the math again. So they want you to go here and think, is it reasonable? And this is because we took a sample and we found about 5.29%. And to confirm that number, we go over here and we say of the U.S. adults, what percent think it has an excellent value? And it's basically 5.3 as we saw in the problem. And so the sample probably gives us some insight, so it's reasonable to believe that. It doesn't mean it is that. The sample is an estimate. We want to understand the population of interest. My phone is buzzing like crazy. Who's buzzing me up? They left a voicemail. Good for them. People don't leave voicemails these days. Please leave me a voicemail if you call. The sample is representative of the population of the U.S. Therefore, exactly, we would never say exactly. Samples give estimates. We would have good reason to believe. The sample is likely, cool, a representation of U.S. adults. So the true value may be close to this, but not exactly because this is an estimate. So the key things to know right here, we always talk about the key things to learn from these questions, is samples are estimates of the truth. That sample of US adults is an estimate, and we found about 5.3%. So it's reasonable to believe the truth is probably near 5.3% for all US adults. Good stuff. Might take these out because don't have any sound. Nima, do you have a research group asked? I think, wait, is it this one? Nima, is it this question right here? This is a research group asked, and it might be this one. You can leave voicemails on FaceTime now. And what? Oh my gosh, I might do that for my wife now. Aaron, that's cool right there. I appreciate that. I get random buzzes, and then I call back and it's like, hey, we'd like to give you a survey. And I'm like, no. You know, it's one of those like not real messages. So a not real message. Isn't that still a message? Oh, tell me if this is yours, Nima. Because this might be it. The homework question might have it. Because it is a research group. Oh, it's not it? Let me know how yours looks. You could post also on the Discord, and I could see it directly. So if you post on the Discord and say, hey, Brian, I posted on the Discord, messaged you, I can find exactly it. And so we will try to find it. Hey, Nick. Hey, Nick. We'll throw Nick some points. I think Nick, former student right there. Good to see you, Nick. A research group of 2,137 U.S. adults, 10,071 college professors. So they give you the row percentages right there, the row totals right there. You got this, Nick. You got this. What is the conditional distribution? So notice this is of the presidents. We're doing the same sort of math, just doing it a bunch right now. And you're just going to take and do 30 divided by 1071. 30 divided by 1071, the total there is. And you're going to just type this number in here and times it by 100. So you're going to do that next 227 divided by 1071 times it by 100. I'm putting it over here so I can actually do it on the other screen and then type the answer. Post it. Thank you so much, Nima, right there. And I'll find that exact question. We'll do it next here. Thank you for doing that. That helps me find the exact question you're working on, and then you get it done. To one decimal place, this one might be pretty easy. A lot of times math errors are what gets you on these. 21.2. I'm doing it off the screen. I'll say what I'm doing. 630 divided by 1071, because we're doing the conditional of U.S. president, of college presidents. I say that every semester. 58.8. And then of the presidents who thought they were excellent, 481 divided by 1071 and 17.2. Is yours the one that has, might be similar. And then this one right here wants you to remove out the negative and poor. Now, this is where people usually get confused. A little bit off topic. Yeah. The visualization playlist helps out with that, but I do also have a jump playlist, Bailey. I can find that right after this video here too. Yeah, Nima, did I not send it to you? Sorry if I didn't send it. I'll post the jump playlist. This one is a bit weird in how it wants you to solve it. Like usually students get stuck on this one. I also think I sent out a video earlier on it. What you have to do is you have to take and remove out the I don't know. Is that it? And I think it wants you to group together these right here. We'll go take a look again. So it says only the poor fare with the good or excellent. So it wants you to put it into these groups right here. And we have to remove out the I don't knows. And that last group is put together. So the issue is there were 62 I don't knows. So you have to subtract that out of the total to get the new total. So this is where usually students make an error, is you take, for Bash writing questions and code answers, yes, nice job, Nick. So you take 2137 and subtract out the 62 right there. And there it is, 2075. And so the new total is 2075. And now we divide these by that number. So we're just taking 325 and dividing. So you're just going to divide, and then add those up and divide. So now we're going to do that right here. I'll do it on the main screen. You're literally just taking this number right here and dividing all of these by it. So 325 divided by 2075. Okay, whoops, here we're going. There we go. And 2075, I got to remember. Okay. 325 divided by that. 5.2 right here, one decimal. Next one is 903 divided by 2075. That's not it. 903 divided by 2075, 43.5. And next we have, last but not least, 744 plus 103 divided by 2075, and that's 40.8. You're welcome, Bailey. 40. Did that help out? Those videos right there, I go through pretty much all the data analytics and show pretty much everything you need to know for data analytics. Really? What did I do wrong? Oh, that's 40.8. Let me look at my answers right here and see if they add up. They don't add up, so I automatically see a problem with this. I am going too quick. Brian, slow down, man. What are you doing? 325 divided by 2075, and that's 15.6. So once again, Brian can't math today, and that rounds to 15.7 actually. Did we math right? We did math right. Once again, if you're wondering what I was doing on that question, which I did say is one of the hardest questions, and then I made an error. I was doing Wacky Wednesdays. Crash, you know what's up. You know what's up. It's Wacky Wednesdays. Wacky Wednesdays. Thank you everyone for bearing with us right here as we have Wacky Wednesdays. Wacky Wednesdays. And let's go find Nemo. We're gonna pull up the question you mentioned right here. And so let me go find it. I think you posted in Stat Nation. I see Stat Nation. Here it is right here. Research group. I see it's got the multi-part. And feel free to use Command Shift 4 or snipping tool. My eyes are so bad. My eyes. And thank you, Nima. I'm gonna put a 100 underneath this. Snipping tool is really great, but you might be on like your phone using Discord, so that might be why. A lot of people use phone Discord. I'm like one of the few people who doesn't use phone Discord, so I can see why people might do it on their phone and then send it. I use computer Discord, so I understand. My eyes are so bad though. I'm like that fish in SpongeBob being like, my eyes. Of course, that's because the king. SpongeBob references. Let's go over here to the quiz. Replace questions. And here we go. We got the quiz up. We're bringing the quiz over. A research group. Ooh, there's some tough ones on this. Oh, that's no. Thank you so much, Nima. I'm throwing you another 500 points. I appreciate it so much, and I think people start to understand how to use Discord better after they use it a little bit. It just becomes like more, more easier. That's words, right? So I really appreciate you checking it out and trying it and using it. So huge shout outs, because it's a learning curve. Everything, you start with being like, how do I use this? And then you get used to it and like, oh, that's how I use it. Okay, 1913 right here, Stat 201, Chapter 3 quiz, a research group. Okay, so let's take a look at the research group question. We got the same sort of data we've been working with. Yeah, Aaron, post on Discord, get those points. Check out those pets in the pets channel, the photography. So here's the data. And now it says, what % of college professors think it has a poor value? So what kind of distribution do we call this when we say what % of college professors? What is that distribution called? I'll start writing the math out here. When we say what % of college professors? What % of college presidents? Yeah, Bailey. They're awesome. Thank you so much. And we keep making new ones, and I gotta make sure all the permissions are right. I really like the social channels too. Mainly, I don't know, supposed to go to those and just see all the cool pets and stuff and talk about recipes. I gotta make that burrito. So what % of college professors think it's a poor value? What is this distribution called? What % of college professors think it's a poor value? What is this distribution called? So there's the marginal distributions, which are in the margins, which we don't see right now. There's social channels on the Discord, yep. Talk about like pets, and I could give you that role. Yeah, here. You can delete the role if you want. But now you can see the social channels. Yep. So if you don't want it, I can delete the role. Not continuous. Good, Aaron. Good try. You're very close. Aaron, we're throwing you 500 for that. It's called conditional. Like you're setting a condition. Like given someone's a college president, what's the probability they think it's a something value? A poor value, conditional. We gave it a lot of points on that. So keep up those answers. So poor value, and we need to do 35 divided by how many college presidents there are, because we would just take the total over here in the margins, which they give us, which is 1048, which is going to be about 3.1%. Let's find out. So 35 divided by 1048, 3.333, which is exactly, so 3.3. So you take the total presidents who think it's a poor value divided by the total presidents, 1048. What percent of US adults think that it's either a good or excellent value? And so with this right here, we want good or excellent for US adults. And so now we go up to US adults and we go good or excellent. So it's going to be these two numbers added up right here. And then we're going to divide by the total. So it's those two numbers right there added up together divided by the total. 744 plus 107 divided by the total. So here we go. 744 plus 107 divided by the 2152 US adults. Times that by 100 and round to one decimal, giving us 39.5. Can I copy that? Yes, I can. And now we're going to do the same thing for presidents right there, college presidents. We're just going to take the highlighting of the conditional distribution and bring this down to here and add up these two numbers. Points. There's a lot of secret commands. Like, I think there's secret commands for you right there. There's a lot of secret commands. 617 plus 183 over the total of college presidents. Mubot might not respond to me today. He might be mad at me. Pint hype, let's go. I got pointers wrong though. Pints. It was a student accidentally typed pints one time like that, and then I made it pint hype. And then students still make that error to this day, and then Mubot will say pint hype. Divided by 1048. We're just adding these two numbers right here. 617, 183 over 1048. Because 1048 is the total. Then we're timesing by 100 to turn it to a percentage, and then we're copying and pasting. Visually speaking, so you can see the visual on it again, you're adding up these two numbers. The table gives us the total of like 1048. You could add up these and also get the total, but there you go right there. Okay. And on average, the presidents think it's a better value. So college presidents had a better opinion. The last one right here, 4.97, is the US adults who think it's a poor value. You don't have to confirm this number, but you can. You could go 328 divided by 2152. Is that right? No, I think it's higher education is a excellent value. So we're doing excellent. So I was like, math doesn't work. 107 divided by 2152. Notice that this is the 4.9% they speak of. More specifically, timesing by 100, the 4.97% they speak of. So this is a sample of US adults and college presidents, maybe all the college presidents. That's a lot. And with this sample, we get an estimate of the truth. So I would say the sample is likely representative, and the true value may be close to this, not exactly. It's just an estimate, and we should get that 100. So good question. Does that help out? I know it did a little bit quickly, Nima, and I will say this. At the start of this video, we did basically the homework version of this, so let us know. There's also the homework version of this to practice. So if you're stuck on it, I did another walkthrough, so I did this one a little bit differently. I try to like mix it up. When I do it at a different time, I kind of give it another spin. So you're welcome, Nima. And yeah, if you ever have questions on what I'm doing, if you're like slow down, just let me know. But hopefully you got that 100 on this, and we're gonna head back. I didn't turn on the lights today, and I almost feel like it looks better. Wait, tell me this. I'm gonna turn on the lights. I want to know if it looks better or worse. Turn on lights. Got to turn on the lights. I'll walk in front of the camera. All right. Need people's opinions. Better or worse? See, now I'm yellow. Camera's probably adjusting. Now I got bright spot. I don't know, it's probably better, right? Lights are adjusting. Watch people say it's worse, and I'll be like, here, go over here. I guess, is it better? Did I do my lighting right? We have a lot of natural light in this room right now. Your head running through the and we're so lucky. We've got like multi cameras in this room. It's really nice. You can swing by the office and check it out. I have 4 monitors. Better with the I think so too, Bailey, right? And you can see it more from back here. Like you can see the lights hitting my face. Got light. I'm just gonna do this. There we go. That's how we do lighting here at Stat 201. Like, hey everyone. Oh my god. All right. Oh, there's the green screen on my face, or because hit the chroma key. It's gonna bump the mic. Okay, let's get serious right here. Fun's over. I've had to learn a lot about lighting and microphones, and like I said, that's why a lot of teachers especially, when I understand it, it's like I don't have time to learn about microphones and lighting and chroma keys and green screens. But I'm really lucky I get to do this kind of stuff because what do people think about the YouTube experience as I load up the homework? Like, I don't want to put words in your mouth, but I'll say I think it's really special. It holds a special place in my heart that I get to teach on YouTube, and it's something so unique, and it's different than other online classes. Like, it's not like a Zoom class. Nothing is Zoom. Let's go back and do the homework. So, it's more like a social experience here. I say it's just we're hanging out. We're just doing work. That's what we do. We hang out, we do work, get work done. Okay, we got question number 3. I think, yeah. Here we go. Timestamp 2703. Yay! Thank you so much. And accessibility is huge. I often try to type or display things on the screen. You'll notice in class, like, you'll see my wheels start turning where I'll be like, I should write this out. Like, if I think it's super important and I'm just saying it, I'll try to write it out so it's visually on the screen. I want to do that as much as possible. So trying to make everything accessible. Okay. A survey of 2,999 undergraduate students asked about respondents' diet preferences, carnivore, omnivore, vegetarian, thank you, Bailey, and political alignment, liberal, moderate, conservative. A stacked bar chart of the 285 responses is given. You know what? All the rage lately has been like carnivore diet or OMAD, 1 meal a day. My diet preferences are drink water, eat fruits and vegetables, don't eat too many fruits that got high sugars, eat some leafy greens, and eat some protein. Protein, leafy greens. Drop your diet advice, but try to and limit sugars. Limit sugars. Gosh, I'm bad at that. There's a big bag of York peppermint patties. Like, I'm talking the big bag. I've eaten that in a day. I've drank a 12-pack of Mountain Dew Code Red. Talked to my former roommate. I got problems. Anyways, back to the question. What does the plot show? Shows a strong relationship. The strong, yeah, exactly. Me too, Bailey. I'm not OMAD. You mad, bro? I'm not OMAD. Carnivore, omnivore, vegetarian. It looks to me like vegetarians are more likely to be liberal, just via this graphic. It doesn't mean if you're liberal, you're vegetarian. It just means vegetarians have a higher proportion of liberals, according to the graphic. Omnivore, you're seeing right here, less liberals, more conservatives start to come to play, more conservatives here. Frankly, of carnivores, more people are liberal than are conservative. And so with this graphic right here, you do see an association where somebody's diet is associated with their voting trends. And with that, what does the plot show? Well, it's showing, and I always hate the way they display these. We could get a question wrong. Vegetarians tend to be more conservative. No, vegetarians tend to be more liberal than those with their diet preferences. Carnivores tend to be more conservative. Yep. And frankly, I get a little bit mad because it's kind of a mix down here in the carnivore diet. I've heard Mediterranean's a good diet. Oh, yeah. Yeah, well, you know what, Bailey? They say the best diet is one you can stick to. Like, that's the truth right there. Like, the best diet is one that you can stick to that helps you, like, with your goals. You can't go on a diet that, doesn't help you with your goals and you can't stick to. So that's truth right there. The difference is I say it's probably real because these are big gaps. So to kind of expand upon this, because people wonder when the difference is real, I like to do a test A versus test B where people are told, like, here's the pass-fail rate of a test. So if you have test A and test B, and this is the pass rate and this is the fail rate, which test would you want to take right here? Like, the pass rate is that black bar. Would you want to take A or B? Would you want to take test A or test B in that instance? In instance 1 over here, would you want to take test A or test B? Very clearly, don't worry if you don't know stats. The statsy people would be like, give me B. Aaron, you're right there. Give me test B. Give you some points. Now over here, why would it really, and we could put the difference like this. Why would someone say to these? When you say test A versus test B over here, someone might say because the conditional distributions are basically good to see Noel. The differences are very, very what here on version 2 of this example. On version 2 of the example, the differences are very, very what? Which they might just be like, like whatever. basically, they're basically the same. So if you took version A, you passed at about this rate. If you took version B, you passed at about this rate. So there's really...
It doesn't matter!
Doesn't matter. There's not a difference. Ayush, good to see you there. Ayush, awesome. And feel free to ask questions. We're doing the homework. And the differences do seem to be real here because there's large gaps and they look to be strongly associated. If they're independent, then you would say in graphic A, right, or graphic 1, the test you take is associated with passing and failing because there's big differences. They do not appear to be independent. They appear to be strongly associated. Graphic 2, they appear to be independent because knowing if someone took version A or version B would not be associated with them passing or failing. So we should get it right. Yay! We're 3 questions away from being done with this homework. So thank you for swinging by and getting the homework done with us right here. 31, 32, 03. Okay. So this question right here, we are doing researchers checking out Swedish men eating Swedish fish. This one gets a lot of people, though, because it's tricky. This is maybe one of the hardest homework questions by the way it's structured and what it asks. Let's examine the graphic first and understand what we're seeing. First off, for some big points, what is this graphic called on the screen? This graphic, which is a visualization of 2 categorical variables. Did you get prostate cancer, and how much fish do you eat? So what is this graphic called? I might re-screenshot it because I think I missed some of it. Yeah, I did. This is chapter 3 homework. You bet. It's called a mosaic plot. Yep, and it's up there at the top. Yeah, don't worry. Use every graphical hint you can use. Let's show you those points we say we're going to give. It's called a mosaic plot. A mosaic plot is the visualization of 2 categorical variables. And a good thing and way to know that or remember is to look at this graphic right here and see mosaic plot in the bottom right corner. If you're watching these office hours, screenshot this. You can pause the video and you can see all the different kinds of visualizations we will be talking about mostly through the semester. So what you'll notice right here on the bottom, what does this indicate to you right here? In their study, there were less men who what? In their study, there were less men who what? In their study, there were less men who what? This question is probably one of the toughest questions. Not this one, but the whole of this question. In their study, like the length of this marginal distribution, because that's a margin right there, telling us only the distribution of prostate cancer. And so when you look at this, exactly, there were less men who got prostate cancer. That says nothing about their fish consumption. This is just less men got prostate cancer, more men did not get prostate cancer. And that's what we learned from the marginal distribution down there. Then we look of the men who got prostate cancer, what was their diet by looking in here? And it looks very similar. So let's try to answer the questions and see what we learn. First off, about what % of all men in the survey were diagnosed with prostate cancer? Now, this sounds like a really tough one, but I just want you to take a guess of how wide this bar is in terms of the length of the whole thing. Just take a guess. Like if I said this whole thing is 100%, that's 100% total. What % is this of the 100%? Just take a guess. Don't worry about being wrong. And you know what, Nima? That's worth some points. And you know what, Aaron? That's worth some points too. Because both of you guessing 7%, and also I'm purposely gonna try to go through the question really quickly. 7% and 10%, I'm not even kidding. There we go. Let's go back and up, good. 10%. Those are right. It's close enough. This question, I think, has a big boundary. Don't enter things outside of that, but 7%, 10%, it's got a big boundary of like 5 to 15%. Now, don't enter in 5 and 15%, but those were close enough. It's like, nah, 7. Bailey, I'm not even joking because I want to see it now. I want to confirm that, Bailey, you would have been right. Here we go. 5%, I'm pretty sure that's within the boundary. So Bailey, let's show you some more points. All those answers were correct. I think it's very close to 7% because one semester I like broke it apart. So you're just meant to, it's like about what % is it? So you're meant to look at it and be like, that's about 7%. It's a very lenient question. It's like you can enter anywhere from 5 to 15 because I've kind of checked its boundaries. So I think it's a very fair question because you should just understand it's 5 to 15%. And so that's what that first question wants us to do. And now the next one's where it gets tricky. There are more men who blank and never seldom ate fish? Okay, let's read the question. Are there more men who had cancer and never seldom ate fish, or more men? Now, this is talking about the total men. More men who had cancer and never seldom ate, or more men who did not have, and it just wants to know in total. So we're talking about is if I were to give you a gold bar, which of these gold bars would be bigger? You ready? Is it this gold bar right here, which I can't highlight through that way? Is it this gold bar right here? That's silver gold bar right there. So a silver bar. Or this one? Like, which of those covers more area? That's what it means by more men, because the one that has more area in it would have more men in it. And we're not talking about the height of it. We're talking about just like the amount of it. Is gold bar 1, which is the silver sliver right there. We're talking about this thing right here. Is that bigger or is that bigger in terms of amount? You can melt it down into another thing. So you've got this big long one like this, and you've got this other one that's a little thicker like this if we were to scale them up a little bit. So this is like a bigger visualization of 1, and this is a, and you make it slightly bigger. Yeah, 1 is bigger. It's not as thick, but it's way longer. So scaling them up, you would see like, well, 1 is just way longer. I mean, it's like half the width, but it's way longer. So there are more men in this. There are more men over here because the amount of area it takes up. So it's of the did not, because there's more men in there because it takes up more area on the graphic. Now it wants the percent. So now we're looking at the actual height of it. So within here, which of these has a greater percentage? So to look to see which one has a greater percentage, really? There we go. To do the greater percentage, we have to go in here and look at this. So which of these has a greater percentage, 1 or 2? Which is 2. So there's a higher percentage of men who had prostate cancer who never seldom. And these differences are likely by random chance because they're small differences, but there are a higher percentage of men in graphic bar 2, and percentage, not amount, percentage. So that's where it's really tricky. I don't love this question. It's pretty good, but if you see the answers, we'll do more review. Okay, let's do the next one right here. Out of the way. It's a good question, but I feel like the learning on it is not as strong. It's mainly look at the amount of individuals in a group, look at the conditional distributions. So it's teaching you conditional distributions. Pew Research Group, it's those college professors again, or college presidents, and here we see a mosaic plot. Now, what do you notice about this mosaic plot immediately when you see the poor? The poor in the mosaic plot is mostly associated with whose? The poor is mostly associated with whose? The people who thought poor is mostly associated with who? The adults. The people who thought excellent is mostly associated with college presidents. And great job, Abigail and Aaron right there. And Chloe, good to see you, Chloe. So you can look over here in the poor is mostly associated with U.S. adults, and the excellent is mostly associated with U.S. president or college presidents, and then the good is also associated with college presidents. So we see a strong relationship where college presidents are more likely to say good and excellent, and U.S. adults are more likely to say things like poor or maybe not as good. And it kind of makes sense. College presidents shouldn't be talking ill about their universities. So what you doing? What you doing, folks over there? Come on. Speaking against party opponent statements. I'm learning law. Don't ask me why. Oh, so for the mosaic plot, about what percent of the respondents were college presidents? And so, well, so it wants percent. So how many total people were surveyed? Tell me in the chat how many total people were surveyed. How many total people were surveyed? How many total people were surveyed? You can kind of look at it. You can kind of get the answer by looking. That's about a third. Oh yeah, and that is the people. Noel, good answers. That's how many people were surveyed. How many? What was the total sample size? So you are correct, Noel, right there. That is the total people who were surveyed. What is the total sample size? Great job, plus. Exactly. Nice job. Everyone chiming in. We got some teamwork makes the dream work over here. And so we're going to do 213, which is the amount of U.S. adults, plus 1055. And huge thank you. I'm throwing out points like crazy. I really love these office hours where everyone's just chiming in. I look over to the chat and I get happy to see that. So now we divide 1055 by the 3198. We type it in the right way. And we get that. And I said about 33%. And you should look at the graphic and you should say, is that about a third? So you can see here, is this a third of the whole thing? It does look to be, and that's a marginal distribution. Yay, marginal. For the mosaic plot, is it easy to see there are more US adults who said college provides an excellent value, or more presidents who said it provides an excellent value? Explain why. Now, this is where they're talking about the amount. And when they say more who said it's an excellent value, what they're comparing is this to this. Is it easy to see which of those gold bars is bigger? They're saying more as in amount of individuals. Like the last question saying more is an amount. Like, is it easy to see that there's more area inside of there or area inside there? Like if I said, does that square have more area than this circle? You'd say, yeah. But if I said, does this square have more area than this circle? You might say, maybe. It's hard to tell. It's hard to tell because if you start like breaking these down and trying to restack them, it's hard to tell if this has more area than this. It's not an easy comparison. Like, which of these is bigger, number 1 or number 2 down here? Which of those has more area to it? And we're talking just mass area. It could be 1. I think the area is hard to tell. And down on the bottom, it's easy to tell this is the right answer. But up top, it's kind of hard to tell between the 2 of these, which of them take up more mass. So the answer is, it's kind of hard to tell for that one. And they'll get to another one. This is just like the last question we did. So is it easy to tell? No, because it's not easy to compare the area of the 2 rectangles. Because once again, we're comparing the area of these 2 rectangles, and they're of different shapes. So I don't know which one has more. Is it easy to tell the percent who said it's an excellent value? The percent. So how would you tell? So answer this in the chat. How would you tell? What kind of distribution would you look at to see the percent of college presidents who said it's an excellent value versus the percent? And now we're looking at this right here. You'd look at the what's. What is the term when you look within a variable at the distribution of the other one and you compare that to this? That's what we're comparing right there. What is that called? Not margins. Good answers, Aaron. We're throwing you 500 points. Keep those answers coming. The margins is on the outside. So the marginals would be over here if there was a margin, and down here. You're very close. It's not called marginal. Not called, it is C. Noel's on getting us closer. Put them together. It starts with a C. You're right. And it is categorical data here. We are working with bivariate categorical. Not correlational. Correlation is only between 2. I'm saying a huge thank you, another 500 points. Everyone's getting crazy points right now. It's called conditional. And Bailey got it right there. Conditional. Great job, Bailey. Only 200 points for the right answers, though. So all those answers got lots of points. So it's called conditional, and it's very easy to see within the conditional distribution that way more college presidents think it's an excellent value versus the U.S. adults think it's an excellent value. So given someone's a college president, what's the probability it's an excellent value? It's way higher than given somebody is a U.S. Individual. So yes, because the proportions, and that's talking about the conditional distributions, like the proportion of area it takes up within that. So they call it proportion. I just say it is. For the mosaic plot, do you think there's an association? Yes, because they are very different or similar. So think about this. If we're saying there's an association, it'd be because they are different or similar. When do we say that there is an association? When they are very what to each other, the more what they are. Then the more that they are, the bigger the association. So I think there's an association because they're different, which this is our example right here of really there's no association here. There's a big one here. Now, when is there an association? Like if you have an in-between graphic where it looks kind of like this, it can be a little subjective till we get to the idea of p-values. So the bigger the difference is, the stronger the association. Yes, because the proportions or the distributions are very different, and that's why. Last question on the homework. Does anyone have a quiz question you want to do? Full homework done right here. And thank you, my office hours crew right here. I thought about having a thing called the A team. Maybe I need to start it up. Okay. We got the carnivore, omnivore, and vegetarian diet. Huge shout out to first Wednesdays of the month here at UT. I got a chicken sandwich this morning. It really made my morning. I need some food. And so shout out to the group putting that on, associated with UT. Here we are. Get that chicken sandwich. So take a look right here. This is a really, okay, I'm gonna throw in some big points. This is a trick question. Is this univariate or bivariate? Is this univariate or bivariate? Trick question. Welcome Wednesday. Shout out to the Welcome Wednesday people. Always good stuff out there in humanities outside of HSS. Swing by first Wednesday of each month. They got some chicken sandwiches. They got some coffee. They probably got some orange juice. If they don't have orange juice, that's not my fault. Aaron already knows it is actually not univariate or bivariate. Let's take a look at the variables. We have variable number one is going to be your ideology, your political ideology, and variable number two is your diet, and variable number three is sex. So it's actually multivariate, trivariate. It has three variables. So they're being a little tricky right here. They're throwing three variables into this mosaic plot, which you can do. It's just a very odd looking mosaic plot. Who was most likely to be a carnivore? Who was most likely to be a carnivore? Sometimes I get part of this one wrong. That's some wacky stuff. Who was most likely to be a carnivore? Who is most likely to be a carnivore? Men. Which men? Which men? You are right. Which men? Which is what's funny is even of that group. Exactly. How many questions? No, a good question. How many questions they have to ask to make this graphic? They'd have to ask, what is your gender, or what is your sex? What is your diet? What is your political alliance or political affiliation? So those things right there, they'd have to ask that. And we can see here, conservative men were the most likely to be carnivores right there by a mile. It's like, just say, I'll have steak with a side of steak. Medium rare, Pittsburgh style. Some people just eat all steak. This dude on YouTube is just like, all steak. Hey, that's fine. That's you. You do you, man. It works for you. You keep doing it. I can't afford all steak. So with this right here, we see the most likely to be vegetarian, female, liberal. But here's the thing. If you went up to a liberal female, even though they're most likely to be vegetarian, they'd probably be what? Think about this. If you spoke to a liberal female, they'd probably be most likely what? Now, they are the most likely to be vegetarian of all the groups, very close to a moderate female who's a little more carnivore, but all these individuals, everybody is probably an omnivore. A lot of us are, pretty much. Even conservative men, omnivores. So there is some relationships right here or associations between somebody's gender and their political affiliation and their diet preferences. We do see some because of these gaps here, these gaps. Let's see what they ask us now and think about what we need to know. Okay. Are there more men or women in this survey? We need to look at the bottom bars. Which bar looks to be bigger for all groups? Are there more men or women? So you look at the bottom bar right here and you compare. Are there more men or women? There's more men. You can see here more men, more men, more men. And that is the margin down there. So the marginal distribution indicates this. No keywords like what is a marginal. So men, because the marginal distributions, the total of the bars, so we're doing the total of the margins is larger. So that's how we do it. Does this appear to be an association? Yes. I'd say a strong. Between politics and gender. Okay, it wants politics and gender. We got to watch out. Go a little too quickly and get it wrong. So it's weak, if anything. I'm a little scared. I think this is the one I always get wrong. If you look here, this is like a 1-2 ratio, 1-3, and 1-4. Does everyone see what I'm doing right here? Like, how much bigger is the male distribution to the female? Does that make sense? Let me zoom in on it. It's not exact, but does everyone see there proportionately there's more men as you go towards the conservative? Like the whole area right here, if you think about it, this is like 1 unit and this is 4 units respectively. Like if I divide this up into like 1, 2, 3, 4, this would be one of these units inside of here. And if this was like, one might be 1 to 2. Like then this would be one of these units, and that might be a 1 to 2 difference. It's not as strong as what we're going to see. That'd be like a 1 to 2. Really computer 2, and this would be like 1.5. Does that make sense? This is a tougher one because I wouldn't display it this way. I don't like that. I'm going to say weak, and it looks like because the relative proportion of females becomes smaller as people become more conservative. Is it strong? Really? That's such a subjective question. Like I said, I was ready to get it wrong. I literally second guessed myself. I was like, I feel like it's strong, but then, oh no, I get it wrong. That's what I do. If I get a question wrong one time, I'll flip it to the wrong answer each time. Does there appear to be an association between politics and diet? So now we need to look at the politics scale right here. And you notice as people get more conservative, they get what? More carnivore. So now there appears to be a strong association. Don't you say I'm wrong. And people tend to become more, eat more meat. So eat more chicken. So eat more meat as they become more conservative. And last but not least, does the association between politics and diet seem to differ from between men and women? And we do see some differences right here. So especially at the very end here, you'll notice that there's a big gap between men and women. So it's bringing in the trivariate. This is, one of these days we might remove this question. There's a gap over here too. Really, computer? Never rest your arm against your screen. There you go. It seems to be that there are differences that are between men and women within their political affiliation and their diet. So the difference in proportion of vegetarians between liberals and conservatives. Vegetarians between liberals and conservatives. Oh my gosh. The difference between proportion of vegetarians between liberals and conservatives, okay, is, let me look at it again. So vegetarians and liberals and conservatives over here. See, there's a big difference where females have way more vegetarians. Is larger for women. Yeah, because there's way more women. So it's talking about, somehow, let me highlight it. 90% sure I know what it's saying. It's saying this compared to this over here, which is nothing compared to a huge bar. Comparing this to this, there's a bigger difference for women. So women have a much larger difference compared to the gray bar you can't even see. So the difference between proportion of carnivores between liberals and conservatives. So now carnivores is going to be where we see there's way more men carnivores. And now it's talking about, really, one graphic. It's talking about, I'll do the same sort of arrows over here. And this is the last one. And then we do another one. So now it's saying females, compare this to this. And there's somewhat of a difference. And then it's saying also compare, compare this to this. And you notice the blue bars right there are bigger. There's a bigger difference for men. So now we'd say that there's a bigger difference for men. We should get it right. There we go. Can you please explain how you're reading the graph about the politics part? I'm confused on how you were reading it. So the politics is going to be, these are all the liberals. Correct. So let me go over the graphic again, and this won't be on the test. That's why I'm hence like, maybe we just, I say to Terry, like, this one's just a lot. We shouldn't make a trivariate display. If it's too much for us and we take stats, then it's too much for anyone in the world. Truly it is. These are all the liberals. These are all the moderates. These are all the conservatives with a nice UT orange. Within the liberals, we have the females and we have the males. Within the conservatives, or within the moderates, we have the females and we have the males. Within the conservatives, we have the females and the males and their diet preferences. It's a lot. They should only have displayed 2 variables at a time. So each of these bars, you have to think, what does it represent? Like this bar right here is the diet preferences of who. This bar right here is the diet. It's a conditional distribution of the diet preferences of who. That bar right there is the diet preferences of who. So that bar is the diet preferences of who. Who is that the diet preferences of? Moderate males, exactly. That bar is the, who fall asleep? That bar is the diet preferences of moderate males. I don't love the way this question is asked. A lot of times our questions, and let's do this. Let's end with Canvas content. This is kind of a good spot to end on. We've got a little bit of time. I've got class coming up here, but we can probably do one version of the Canvas content. And I want you to see what the test looks like. So number one thing is, what does oh, Noel knows. Noel, you're feeding my addiction. Let's throw you some points. I'm starting to have headaches, probably caffeine deficiency. Brian needs his caffeine stat. Give Brian some Red Bull. He needs that Red Bull. It's like, I don't want Red Bull, I need Red Bull. And when you need Red Bull, that's a responsibility that only an adult of my maturity can have. Old memes. You get that reference, you probably went to college with me. Okay, so this is Canvas content number 3. Okay, so I want to go specifically to this. These are the kinds of questions you would expect from chapter 3, where it says something like, what % of people were neutral about the chocolate they tasted? Who can tell me how to answer this in the chat? It says, what % of people were neutral about the chocolate they tasted? This is how test questions could look. I think we literally have this on the test in some versions. What % of people were neutral about the chocolate they tasted? What % of people were neutral? How would you math that? What would the answer be? What % of people were neutral about the chocolate they tasted? It might be. That sounds about right. Chloe, great job right there. Because you go to the marginal distribution, because it's of all people, like what % were neutral? And that's in the margin. There it is right there, 23.1 to 2 decimal places. We have pretty nice boundaries on these. Now the next one says, so here's 2 more at the end, what % of Marvel superheroes can fly? So how would you figure out what % of Marvel superheroes can fly? Go ahead in the chat, try to figure this out. Once again, remember, these are test questions, really good practice. What % of Marvel superheroes can fly? What % of Marvel superheroes can fly? See if you can figure it out. And you can show me the math too. You could just type the equation and then I'll figure you could solve it. These are how chapter 3 questions can look on the test. It's not how every question will look, but kind of gets you ready for what we'd ask to be like, oh, we got 2 answers. Let's throw points for those 2 answers. So Marvel superheroes and then flight. What % of Marvel superheroes can fly? And the answer is 115 divided by the total of Marvel superheroes, 14.5. 14.5 right there. So of the Marvel superheroes, what % can fly? What % of students, what is the probability of a student being born in Tennessee? So what is the probability of a student being born in Tennessee? How do you do that one? Another nice and easy one. And great job, everybody practicing. More points. You get points for just trying. What % of students were born in Tennessee? Give it a try. You got it. What % of students were born in Tennessee? Thoughts? Oh, one of the last. It might be. Well, we got some different answers. Let's throw points. So do we want marginal or conditional? Marginal or conditional? What % of students, like everybody, was born in Tennessee? Is that marginal or conditional? Conditional means look within one variable at another. Marginal means just look at the distribution of one variable, like the margins of a table. So what % of the students, which is everybody, were born in Tennessee? It's not good answers. It is marginal. It is marginal. So we're going over here to the margin. What % of the students were born in Tennessee? Then we're going to circle born in Tennessee, yes. And let's take a look. And do 574 divided by 923. It's 62.1. There it is right there, 62.19. That's got it. Don't worry, this is practice. We're throwing you some more points. 62.19. What % of students were born in Tennessee? Outliers in the box plot are 1.5 IQRs above Q1 and Q3. There's sometimes a good reason to remove outliers. If we find good reason to, we can't just remove them needlessly. How would you not divide 15 by 65? Let me take a look. We got 10 out of 10. 15, good question. So 15 divided by 65 would be the question. Would be, of the honors students, what % were born in TN? So that'd be of the honors students, what % were born in TN? Does that make sense? So of the honors students, There you go, right there. So of the honor students, what percent were born in TN? Good questions, Noel, right there. So that's how that question would be phrased right there. Let me know if you have a question on this. It'd be of the honor students, or you could say, given someone is an honors student, what is the probability they are born in TN? Good stuff. Yep. And the honor student is that. Yeah, that's the honor student. And then this way across the table is born in TN. So with that, some points and our fun outro, one of my favorite outros, Shattered 2 outro. Bye. RotoWave! Everyone give shouts to RotoWave. Let's throw 1,000 points if you're still here. RotoWave. Have a great day. Bye!